Next type of instruction is subtraction instruction considering carry status, that is borrow. In that category, the first instruction is SBBRS. Whenever this instruction is executed, content of specified register along with borrow status, that is carry flag status, is get subtracted from content of accumulator and the result is saved in accumulator. That is, the specified register content, it may be any general purpose registers or accumulator, along with the carry status. In the case of subtraction, carry status indicate borrow. So that is subtracted from content of accumulator and the result is saved in accumulator. As RS is any general purpose registers, the addressing mode is register addressing mode. And while converting this instruction into machine code, it requires only one memory location, that is only 1 byte. So it is a 1 byte instruction. So that 1 byte is opcode that we need to take into instruction register while executing. So in order to complete the execution of this instruction, it requires only one machine cycle, that is opcode fetch. For opcode fetch, number of T state is 4. While executing, all flags are affected. Next arithmetic instruction is SBBEM. EM stands for the content of memory pointed by HL pair. Whenever this instruction is executed, content of memory location which is pointed by HL pair and carry flag status is get subtracted from content of accumulator and the result is saved in accumulator. As operand is not directly specified in the instruction, instead it is specified in register pairs. This addressing mode is register indirect addressing mode. When we are converting this instruction into machine code, the machine code size is only 1 byte, therefore it is a 1 byte instruction. That 1 byte is opcode that we need to take into instruction register while executing this instruction. That operation is opcode fetch, and after that we need to take the memory content which is pointed by HL register pair. So that operation is memory read. So in order to complete the execution of this instruction, it requires opcode fetching and memory read, that is 2 machine cycle. In order to complete this execution, it requires 70 states and all flags are affected. Next arithmetic instruction is SBI data 8. Here 8-bit data, that is byte 2, and borrow is subtracted from content of accumulator and the result is stored in accumulator. That is, the data which is given in the instruction along with the carry status is subtracted from the content of accumulator and the result of operation is saved in accumulator. As the data for the operation is directly given in the instruction, that addressing mode is immediate addressing mode. Then when we are converting this instruction into machine code, the machine code size is 2 byte. Therefore, this instruction is a 2 byte instruction. In first memory location, we will save the opcode which is given by the manufacturer, and in memory location 2, we will save the data which is given in the instruction itself. So this byte 21, that is opcode, we need to take into instruction register while executing. That process is opcode fetch. Then we need to take this data into MUP. That process is known as memory read. So while executing this instruction, there is opcode fetch and memory read. Therefore, in order to complete the execution of this instruction, it requires 7 T states. All flags are affected. Next arithmetic instruction is increment or decrements. So first of all, let's see increment register. This is INRR. Whenever this instruction is executed, content of specified registers, it may be accumulator or any other general purpose registers, that register content is incremented by 1. Assume initially the content of accumulator as 10H. Then we are doing INR execution After the execution of INR instruction, the content of accumulator become just 1 1. So as the operand is available in any one of the general purpose registers, the addressing mode is register addressing mode. When we are converting this instruction into machine code, the machine code size is only 1 byte long, that is opcode. So it is a 1 byte instruction. Here we need to take this opcode into instruction register only in order to complete the execution of this instruction. So it requires only one machine cycle, that is opcode fetch. The number of t-state for completing opcode fetch is usually 4. When this instruction is executed, all flags are affected except carry flag. Let's see one example. Assume initially the content of B register is 4A. Whenever this instruction INR B is executed, content of B register is just added with 1. What is the content of B register? 4A. So answer become 4B. All flags are affected except carry flag. Assume initially all flags are zeros. Here number of 1 is 4, that is even. Parity flag will set. Carry flag won't affect. Whatever be the content earlier, that will retain. Then there is no auxiliary carry. Auxiliary carry flag is reset. Answer is not 0. Therefore 0 flag is 0. MSB result is 0. Therefore sign flag is 0. Next arithmetic instruction is INR EM. This is used for incrementing the content of memory pointed by HL pair. So whenever this instruction is executed, the content of memory location pointed by HL pair is get incremented by 1. As M is available, that indicate the operand is not directly specified in the instruction. Instead, its address is available in register pair. So this type of addressing mode is register indirect addressing mode. When we are converting this instruction into machine code size is 1 byte. That 1 byte is nothing but opcode of the instruction. So first of all, we need to take the opcode into instruction register while executing the instruction. Then we need to take the content into microprocessor. That operation is memory read. Then we need to do some addition on that content. That means after adding 1 into that content, again we need to save that content result into that location. So memory read is required and memory write also required in order to save that result after incrementing. So in order to complete the execution of this instruction, it requires 3 machine cycle. One is opcode fetch, taking the opcode of the instruction which is saved in memory into MUP. Then we need to take this M, that is the content of memory pointed by HL pair, into MUP, that is memory read. Then we need to add 1 to that content. So after that we need to save the result into memory location pointed by HL pair. That operation is memory write. So for opcode fetch 4 t states, memory read 3 t states and memory write 3 t states. Total t state for execution of this instruction is 10. All flags except carry flags are affected during the execution of this instruction. Now let's see one example in this INR EM. Initially assume HL pair is pointed by this location, that is H contains C0 and L contains 0A. So in this location C00A, the content, that is M, is nothing but C5. So during this execution, M, that is content of memory location pointed by HL pair, C5 is added with 1. So after adding 1 with C5, the result is C6, that is saved in this location itself, which is pointed by HL pair. Here carry flags are not affected. Whatever be the flag status earlier, that will retain. Now let's see number of ones. Here number of 1 is 4, that is even parity. Parity flag will set. There is no auxiliary carry from lowest nibble to MSB nibble. So auxiliary carry flag is reset. Answer is not 0, therefore 0 flag is 0, reset, and MSB result is 1, therefore sign flag is 1. Next arithmetic instruction is decrement or DCRR. whenever this instruction is executed, content of specified register is get decremented by 1. As the operand is specified by any general purpose registers, therefore addressing mode is register addressing mode. When we are converting this instruction into machine code, the machine code size is 1 byte long. It requires only one memory location in order to save this instruction. Therefore, it is a 1 byte instruction. That 1 byte is nothing but opcode of the instruction. While executing, we need to take that opcode into microprocessor, that is instruction register. That operation is opcode fetch. So in order to complete the execution of this instruction, it requires only one machine cycle. For opcode fetch, number of t-state required is only 4. All flags are affected except carry flag. Let's see one example. Here initially the content of D register is 60. So what is the content of D register after execution of Dcr D? So answer is 5F. Say initially the content of status flags are like this, all are zeros. Here subtraction is performing, that is from this content of D register, 1 is get subtracted by means of 2 complement addition. So answer is obtained as 5F. Here number of ones, 6 is even parity. So parity flag will set. Auxiliary carry flag is not there. Answer is not 0, and sign flag MSB result is 0. Next arithmetic instruction is Dcrem. Whenever this instruction is executed, content of memory location pointed by HL pair is get decremented by 1. That is, from the content of memory pointed by HL pair, 1 is get subtracted, and that content is saved in that location itself. As operand address is not directly specified, instead it is specified by register pair. It is register indirect addressing mode. And when we are converting this instruction into machine code, the machine code size is only 1 byte, that is opcode of that instruction. So while executing this instruction, it required to take this opcode into instruction register and decoder. In order to decode that instruction, that operation is opcode fetch, and after that we need to take this data that is pointed by HL register pair. Then we need to perform some subtraction on that one, and after that we need to save the result of operation into again the memory location pointed by HL register pair. So it requires memory read and memory write. Therefore total T state is 10. Here all flags except carry flags are affected. So it can be concluded that during increment and decrement operation, all flags except carry flags are affected. Let's see one example in Dcrem. Initially assume HL pair is pointing this location 2010, that is content of H is 20 and content of L is 10. In that location the content is M, that is M represent FA. Assume all flag status are zeros. Here we need to perform subtraction from this content, that is from FA we need to subtract 1, and into that location we need to replace it with the result obtained after subtraction. So 0, 1 we need to convert into binary. So 1's complement of that one is this one, and 2's complement we need to add this result with 1. So 2's complement of 0, 1 is EFF. That we need to add with EFA. So the result is obtained as EF9. During this operation carry is discarded. So after execution of this instruction, FA is replaced with F9 into that location. In this result number of 1 is even, therefore even parity. So parity flag will set. Here there is a carry from LSB nibble to MSB nibble. So auxiliary carry flag will set. Answer is not 0, so 0 flag is reset. MSB result is 1, therefore sign flag will set. Next arithmetic instruction is DAD register pair, that is DAD RP. RP indicate higher order register in register pair other than HL register pair. That is for DE register pair we will use D MSB register in DE register pair. For BC register pair the MSB register pair is B. So RP indicate DE or BC. So for example, let's consider DAD D. Whenever this instruction is executed, the content of DE register pair is added with the content of HL register pair and the result is saved in HL register pair. That is 16-bit content of register pair are added to content of HL register pair and the result is saved in HL register pair. If the result having larger than 16-bit data, then carry flag will set. No other flags are changed. Only carry flag is affected during DAD operation. Example DAD B. Next instruction is INX RP. As I mentioned earlier, RP may be any of the register pair combination, that is DE register pair or BC register pair or H register pair. So RP is denoted by higher order registers in register pair. In DE register pair, higher order is D, BC higher order register is B, and HL register pair higher order register is H. Whenever this instruction is executed, the content of register pair is incremented by 1 and the result is stored in same place. Let's see one example. Assume initially the content of HL register pair is 0, 0, EFF. That is H contains 0, 0 and L contain EFF. Whenever this instruction is executed, the content of HL register pair is get incremented by 1. That is 0, 0, EF plus 1. So answer become 0, 1, 0, 0. So when we are converting this instruction into machine code, the machine code size is 1 byte. So it is a 1 byte instruction. As the data which we are going to increment is available in general purpose registers, addressing mode is register addressing mode. Here we need to take the opcode of the instruction from memory location into inside MUP. Therefore, in order to complete the execution of this instruction, it requires only one opcode, that is opcode fetch. And it is to be noted that during opcode fetch, total T state may varies from 4 to 6. In order to complete this instruction INX RP or Dcxr, the number of T states required in order to complete the execution of opcode instruction is 6. Next instruction is Dcxr. Whenever this instruction is executed, content of specified register pair is get decremented by 1 and the result is stored in the same place. When we are converting this instruction into machine code size is 1 byte. So it is a 1 byte instruction. That 1 byte is nothing but opcode of the instruction. So during execution we need to take this opcode into instruction register, that is MUP. That operation is opcode fetch. In Dcxrp and INXrp, number of T states required during opcode fetch is 6 T state. Let's see one example. Dcxsp. SP stands for stack pointer. So whenever this instruction is executed, the stack pointer content, that is 1000, is decremented by 1. So just before 1000 the data is 0, EF. So after execution of this instruction, the content of stack pointer become 0, EF. So when we are converting this instruction into machine code, the machine code size is 1 byte. It is a 1 byte instruction and it is register addressing mode, and during execution it requires only one machine cycle, that is opcode fetch. It requires 6 T state during opcode fetch. The possible this type of instructions are Dcxb, Dcxd, Dcxh and Dcxsp.